Liquid Crystal Display, LCD. Think of liquid crystal displays, or LCDs, as the absolute foundation of the modern visual world. From the dashboard of your mail truck to the high-end monitors you'll be using in your cybersecurity labs at BCC, LCD technology is everywhere. To master this for the CompTIA A+ exam, you have to understand one fundamental, physical, truth. An LCD does not actually create its own light. It is essentially a complex, multi-layered sandwich. At the very back is a light source, which used to be fluorescent tubes but is now almost always a panel of white LEDs. In front of that light is a layer of liquid crystals. When the computer sends electricity to these crystals, they act like microscopic shutters, twisting, turning, and physically blocking or allowing the light to pass through color filters to create the image you see. For your career and the exam, you must be able to contrast the three flavors of this technology: TN, IPS, and VA. Each one makes a different trade-off between speed, color, and viewing angle. 1. Twisted Pneumatic TN. Twisted Pneumatic is the oldest and most affordable form of LCD technology. It gets its name from the physical behavior of the liquid crystals. In their natural state, these crystals are twisted. When you apply an electrical voltage, they untwist to block the light. The defining characteristic of a TN panel is extreme speed. These panels have the fastest response times of all LCDs. They can change a pixel from one color to another in as little as 1 millisecond. In the world of competitive gaming or high-frequency data monitoring, this is a massive advantage. When an object moves across the screen at high speeds, a TN panel shows very little motion blur. However, there is a major trade-off in viewing angles and color. TN is essentially a selfish monitor. It is designed for one person sitting perfectly still and perfectly straight in front of it. The moment you tilt the screen or move your head to the side, the laws of physics push back. You will see color shifting, where the top of the screen looks darker than the bottom, or the colors wash out into a ghostly white. In extreme cases, the colors might even invert, making a photo look like a film negative. Because the color reproduction is often a bit dull and limited to a smaller range of the spectrum, you would never use a TN panel for professional photo editing. But for a high-speed gaming rig or a budget office setup, it remains the most cost-effective contender. 2. In-plane switching IPS. In-plane switching was invented in the late 1990s specifically to kill the flaws of the TN panel. Engineers realized that by changing how the crystals moved, they could change how the light behaved. Instead of the crystals twisting up and down like a shutter, they stay parallel to the screen and rotate in place, or in plane. The defining characteristic of IPS is color perfection and wide viewing angles. IPS is the gold standard for creative work and high-level systems administration. It offers the most accurate color reproduction possible in an LCD, often covering the entire sRGB color space. More importantly, it has a viewing angle of nearly 180 degrees. You can have 5 people standing around your desk looking at the same screen, and everyone will see the exact same vibrant, accurate colors without any washing out. This is critical for collaborative environments or for a cybersecurity analyst who needs to see every detail of a log file from any sitting position. The trade-offs for IPS are contrast and cost. Because of how the crystals are aligned, they are slightly less efficient at physically blocking the backlight when they are supposed to be off. This leads to what we call IPS glow, where the corners of a dark screen might look slightly illuminated or grayish in a dark room. You will notice this most when watching a movie with black bars at the top and bottom. Additionally, because the manufacturing process is more complex, IPS panels are usually the most expensive flavor of LCD to manufacture and purchase. 3. Vertical alignment VS. Vertical alignment is the middle child that tries to offer a compromise between the speed of TN and the beauty of IPS in these panels. The crystals start in a vertical position, perpendicular to the screen, and tilt when power is applied. The defining characteristic of VA is its incredible contrast ratio. VA panels are the undisputed kings of deep, inky blacks. Because the crystals are so good at standing perfectly straight up and blocking the backlight, the dark parts of a movie or a game actually look black, rather than the dark gray found on an IPS. In fact, a VA panel can often produce 3 times the contrast of an IPS panel. This makes them the perfect choice for home theaters or for security analysts who spend all day looking at white text on a black terminal background in a dimly lit server room. The major trade-off for VA is ghosting and motion performance. VA panels often struggle with fast transitions from dark colors to light colors. When a bright object moves across a dark background, the crystals can't always tilt fast enough to keep up with the electrical signal. This creates a smear or ghost trail behind moving objects, which can be very distracting during high-speed action or while scrolling through thousands of lines of code quickly. Summary of performance attributes. When you are out in the field as a technician, you must categorize these by their primary strengths. Response time and speed. TN is the champion here. If your client is a professional gamer or someone working with real-time, high-speed financial data, TN is the speed choice. VA is usually the slowest, leading to that characteristic motion blur. Color accuracy and viewing angles. IPS is the undisputed winner. If the job involves Photoshop, video editing, or a multi-monitor setup where screens are angled toward the user, IPS is mandatory to prevent color distortion. Contrast and black levels. VA wins this category every time. For media consumption or working in a dark environment where eye strain is a concern, the high contrast of a VA panel provides the most comfortable and visually striking experience. Final comparison for the technician. When you are making a recommendation to a client, remember these quick profiles. Twisted Pneumatic TN is the fastest and cheapest option, but has the worst colors and viewing angles. Use it for high-speed gaming or budget workstations where color doesn't matter. In plane switching, IPS offers the best color accuracy and the widest viewing angles, but it is expensive and has weaker contrast. Use it for graphic design, photo editing, and high-end professional offices. Vertical alignment, VA, provides the best contrast with the deepest blacks, but it suffers from motion blur and ghosting. Use it for watching movies or monitoring text-heavy logs in dark environments where the deep black background helps the text pop.